Welcome all to Sungrow online CPD training. We've made some adjustments to the CPD191, installed the solar hybrid and inverter and battery to include now the energy bridge. So pretty much the same as it was, but it now includes energy bridge information. So let's have a look. So we're talking like 20 CPD points. I'll explain at the end how to get your points. Okay, so if you're new to Sungrow, we have been manufacturing inverters since 1997 and we've been in Australia since 2012, and we now have over 100 staff in the Sydney office, so we get plenty of tech support there for you. So we do, amongst other things, we do the hybrid inverter and battery as well. The major advantage of this is if there is some problem, you only need to talk to one manufacturer, i.e. us, and we can remotely, through the iSolar Cloud, we can log into the battery to see if there is any problems or not. This is not possible if you're using a third-person battery. Okay, single phase. We do single phase and three phase, and in the single phase range we do a 5 kilowatt, a 6, an 8 and a 10 kilowatt, and in the three phase range we do a 5, 10, 15, 20 and 25 kilowatt hybrid, which all of them have inbuilt backup. Okay, so on the battery range we have two ranges in the battery, the SBR and the SBH. So we'll look at the SBR range first. These are 3.2 kilowatt hour modules, and you can stack up to 25.6 kilowatts in one stack, like so. You can parallel up to 4 stacks as well, so you can get just over 100 kilowatt hours of storage. They are upscalable, and what I mean by that is you can start off with, say, 3 modules, and as the customer goes they can add more modules. It's an easy thing to do, you just add the modules on top of the existing stack. They have a 30 amp maximum charge discharge rate, so normally you're looking at 6 mil solar cable for these. They are rated at IP55, which means they can be installed outdoors. Please do not install them in direct sunlight, because this direct sunlight carries radiant heat and it will heat the batteries up too much. Please refer to the spec sheet, the data sheet, for the ambient temperatures. SBH range, fundamentally the same battery except it's a higher output. These are 5 kilowatt hour modules and they are up to 50 amps maximum charge and discharge on these, so you're probably looking at 10 mil cable for these. Once again, upscalable, they can be stacked up to 4 stacks in parallel, which means you can get up to 160 kilowatt hours. IP55, keep out of direct sunlight. Okay, so I'm going to go over some important information first, then we'll look at the electrical and the data connections, the battery connections, and the commissioning and testing. Okay, so for warranty purposes, please always use the provided AC and DC plugs and the crimp lugs and the bootlace crimps for the data connections. The standards do say that you do have to use any supplied plugs, okay? So you do need to use these to keep your warranty intact, because you've got to use like for like, and if you don't, there's a possibility of overheating. With the AC crimp lugs, look, that's fine, you can use your own as long as they are the correct size for the cable and the terminal inside. In other words, as long as you've got the correct size of cable hole and lug hole, it should be fine. On the inverters, they have an inbuilt DC isolator for the PV input. That might be on the side or it might be underneath. They all now have an LED display, and everything else just plugs in the bottom. It's plug and play. Up till now, we've included a DTSU 666-20. That will be faded out and replaced by the energy bridge, which I'll talk about in a minute. On the single phase, the 5 and the 6, you might have an S100, which is a single phase CT meter, but the rest of them have the DTSU 666-20. It's a dual channel CT meter, and it can be used on single, 2-phase or 3-phase. As I say, these will be phased out, although you can still purchase them if you want. The energy bridge. Now this is the new device that we've introduced into the system. It will be included in the box in the future. Right now you can purchase it separately through Sungrow. These are made in single phase or 3-phase units. It is a motorized circuit breaker, and it includes a meter, and so it's got internal CTs. Okay, and the main benefit of this, it's going to save you a lot of space in your switchboard, and it will reduce your cable costs. I will explain that in a minute. So using the energy bridge, you put it in your switchboard, and you've got your main AC supply coming in through your main switch, through the energy bridge, and then it just goes on to the bus bar. Okay, and so you've got your normal loads, and you've also got your AC cable to the inverter, your main cable. Now previously that had to be a 63 amp cable, but that is not the case any longer. You basically calculate it on the size of the inverter, the AC size. So if it's a 10 kilowatt single phase, you base it on 10 kilowatts. Doesn't need to be 63 amps. You no longer have to run a backup cable from the backup port back into the switchboard. That is now obsolete, so that's going to save you on that cable cost as well. PV connected into the inputs as normal, and battery, which I'll cover in a little while. There's also a communication cable goes between the two. It's basically a Cat6, Cat5, Cat6 cable, and it communicates between the inverter and the energy bridge. Now how this operates is, when the grid fails, this energy bridge will trip, and it will decouple everything, the entire house, from the grid. The inverter will go into backup mode, and it will supply all your loads out of that AC cable. When the grid comes back on, it will do the usual 1 minute, okay, to synchronize to the grid, and after 1 minute it will automatically, on its own, it will switch back on again and reconnect the inverter to the grid. Okay, now we do have separate training on this energy bridge, so if you do want training on it, give us a hoy. AC coupled systems, once again with the energy bridge. If you have an existing Sungrow inverter, it just connects onto the AC bus bar just the same. Okay, this is optional, the PV. You can actually AC couple this, and what I mean by that is basically it will charge the battery from the AC output of this inverter here, or you can connect more panels, so it's AC and DC coupled. Okay, all the data from this inverter goes up to the iSolar cloud via the dongle, so you don't need to monitor the AC cable coming out. Now, one or two things you need to pay attention to is that AC coupled inverter cannot be larger AC than the hybrid. Okay, so if you have a 5 kilowatt hybrid single phase, the maximum this can be is 5 kilowatts. Okay, and it must be able to respond to frequency shift, because when it's in the off-grid mode, the only way of controlling that inverter is through lifting the frequency up to 52 hertz. So when the loads are satisfied, like maybe the system's producing 5 kilowatts, the battery's fully charged, the loads are only consuming 1, it will ramp the hybrid down to 1 kilowatt, and it will lift its frequency up to 52 hertz, and the other inverter will shut down. Okay, so there is a test button on the app that you can test this function. Okay, third party, like an old Fronius or an SMA, same deal, exact same thing, except to get the AC output of it, you do need to use a second channel. As said before, there is internal CTs, and that's for the mains, but there's also an input for secondary CTs, which you will clamp over the AC output of this inverter, and it will upload to the iSolar cloud. Once again, it mustn't exceed the size of the hybrid, and it must be able to respond to frequency shift. Okay, wiring, it's really easy. So you've got your main switch active coming out the main switch. You go into the top terminals. Your neutral goes to the MEN, the neutral bar, and then the output basically goes to your bus bar. Everything else goes on here. The data cable, on the bottom there is an RJ45, and there's an RJ45 little plug thing here, this cable accessory, which is also included in the box. So you basically run your Cat5, Cat6 between the energy bridge and here, and these are all being pre-terminated and pre-labelled to plug in. On the left hand side of every inverter you'll see this pinout thing here, and it tells you where to plug everything in, and these are labelled. You can see the A2, B2 here, that's the meter one, and you can see the white, green, green, you can see the B2 there. It's into pin number 3, which is this one here. RSD1, RSD2. You can see those are going into pin 6 and 8. And the dry contact COM1 and COM2 goes in here. So it's nice and easy to connect it up. It'll take you a few moments. Now, if you're doing partial backup, that is, you're not doing whole home backup, you do have to wire this in a slightly different way. Okay. Now, so I'll have to mention AC pass-through. In this configuration here, you might have full load on your backup circuits, and at night, if there's no PV, and if your battery is completely discharged, the only source for the loads is from the grid. So the power's coming up that AC grid cable through the inverter and out to the loads, and that's the pass-through. Okay, and it's rated at 63 amps, but the end user may also, at that point, if they, for some reason, maybe they think there's going to be a power outage, they might choose to force charge the battery from the grid. So the current for that is also going to be coming out that AC cable. Okay, so how do you work out what size of cable? Well, we'll look at the data sheet, and we'll take for an example SH5RS, and you see here the maximum charge discharge power, 6.6 kilowatts. Now, it's important to point out this 6.6 kilowatts on the battery side is exactly the same as it is on the AC side. The voltages and the current is different, but the kilowatts is the same. Maximum power for backup load is 6 kilowatts. And if you look here, it says maximum AC power from the grid, 12 kVA. So that's what you have to rate your AC cable size on if you're doing partial backup. Okay. So here's the partial backup here, and in this case you will also need to install a DTSU 666-20, because that's the only way we have of monitoring power coming in from the grid and going to these non-essential loads. So you do have to have the meter in here. You also have to have the meter if you're going to monitor an AC coupled system. Okay. Now, there is a problem in this configuration. This is AC coupling, so if there's an existing system and you decide you're going to install just a hybrid and a battery, that's fine. The battery will charge from the surplus AC of this other inverter here, so instead of the power going out to the grid, it will actually go and charge the battery. The downside of this is if the grid fails, so does that inverter, okay, because it's lost grid. Like that. So your inverter, the hybrid inverter, it will go up, switch over to backup mode, and it will start producing grid. It becomes grid forming, and it will power the backup loads from the battery, as long as the battery is charged, of course. Now the battery could completely discharge, and if the AC power's not back on again, it's going to be discharged. It will sit there. So what you can do is you can also connect some panels, and that will turn it literally into an off-grid system, and it will black start. Okay, so even if the battery does discharge overnight, as soon as the sun comes up, the system wakes up and it will start supplying loads and charging the battery. If you are using the frequency shift function, that has to be enabled in the app. So if you go into the settings in the app, into operational parameters, and down to other parameters, you will see this frequency shift power control. So you just tap that little button there and it will go green, and you've enabled the frequency shift. Okay, the test button is right below, so if you enable it and you want to test it, you have to put it into backup mode so it's not connected to the grid, and then tap that frequency shift, and the AC inverter or the grid inverter should shut down immediately. If you're doing the old system, not with the energy bridge, you also fit this changeover switch. It's in the box, so you see the changeover switch. The purpose of that, and it is not required when you're doing energy bridge, is if you've got your entire house on backup and the inverter were to fail, the house would go into darkness. So this is fitted in the main switchboard, and if that happens, the customer can go to the main switchboard and basically switch it back over onto grid supply. Okay, so if something happens to the inverter, supposing you get a lightning strike and it blows the inverter, it pops and it's not working, they can always switch back over onto grid supply. Okay, now on the AC connections, it is in the manual. It says no tighter than 2 Newton meters force to tighten these up. Please don't use one of these things because you will probably strip the threads. And if you do that, the only way to repair it is to get a replacement AC connector for it, which we will supply for no charge, but we won't pay you to replace it because you damaged it. Earthing, mandatory. This is in the manual, so you must do it. On the chassis, could be on the left or the right or underneath, there's earth terminals. You must run a cable from the chassis back to the earth bar, because when it goes into off-grid mode, it must pick up this earth on the MEN. Okay, and that is for your RCDs, obviously. So no matter what you do, you must run an earth cable from the chassis back to the earth bar. As far as what size of earth cable, well, please refer to AS3000 for that, because that will dictate what size of cable it needs to be. DC connection from the PV, I say we supply the MC4s. Make sure they're properly crimped, make sure the glands are tightened up properly, and they'll plug in no bother. We also supply a different type for the battery so you don't get them mixed up. Okay. Now on this one here, if you look at the data sheet, it'll tell you ISC 20 amps, IMP 16. If you connect a panel that's more than 16 amps, it will clip the input to 16 amps. Okay, so you just need to bear that one in mind. Now, if you are installing a meter, they're pretty easy to install. You install it between the main switch and everything else, so it's on the bus bar. The voltage input is a reference voltage only, so there's no current in there, or minimal current, because it's a few watts. So please refer once again to the standards to see about protecting the cable, but you don't need a large cable for it. Single phase, 2 phase, 3 phase, that's fine. The current transformers, there are 2 channels. One channel is for monitoring the mains, and the second channel is if you have that AC coupled inverter. Now with the CTs, the important thing is it has to be clamped onto this cable between your network meter and everything else. Its entire purpose is to measure any current flow coming in to the building or going out. Okay, so you can put it before or after main switch, doesn't matter, but as long as it's between here and it's before literally everything else. Please make sure you point the arrow on the CT towards all the loads, inverters, and please make sure that you actually put them on the correct phase. If you get the wrong phase, you'll still get data uploading, but it's going to be wrong. I'll give you a good example of that. Phase A, so if you've got the phase A voltage into the phase A input there, and you take the phase A CT and put it on the phase B, your power factor goes to 0.5. So instead of showing a kilowatt, it'll be showing half a kilowatt. Okay, and that'll be on the other phase as well. Don't meter the controlled loads because they're on a different tariff. Okay, and you run your RS485 from the meter to the inverter. Bit more on the RS485. So once again, I said on the left hand side you'll find this pinout diagram. It does vary between models and it tells you where to connect everything. So the ones you're looking for, generally speaking, are the meter, which is always A2B2, and the CAN high, CAN low, which is the battery. Now if you look here, you'll see that's battery connections there, and it goes into pin 2 and 4, which is pin 2 and 4 there. Pins are 1, 3, 5, 7, 9 across the top, 1, 3, 5, 7, 9, and 2, 4, 6, 8, 10 along the bottom. And you can see that we've used those correct bootlace crimps. These are the correct ones because the pins are 50% longer than standard. They need to be to get a good connection when you push these in. If you don't use them, if you twist the wires and poke them in, at some point it's going to get a bad connection and you'll have to go back out on site. So please use these. Okay, so everything's in the box, as I said. It communicates via RS485. Please use shielded twisted pair, 0.5mm or larger. It does have some cable in the box. I think it's 8 meters. That's fine. It's a twisted pair. But if you have to purchase your own, I don't recommend Cat5, Cat6 because RS485 is a 120 ohm impedance system, and Cat5, Cat6 is a different impedance. Okay, so you're not impedance matching, but you are if you buy the correct cable, which is this stuff here. That's an example. I'm not advertising this company, but this is one that I know some installers use. So it's one pair, shielded, twisted. That one's 0.88mm. That's fine. Terminate with the correct bootlace crimps. So there you go. Meter A2B2, which is in pin 1, pin 3. From the meter end, you'll see A and B. So you put your cables into A and B and A2B2. Okay, get the polarity correct. In the box is a 120 ohm resistor. Now that will basically help reduce what we call data reflections in the cable, and it will just give you a better quality signal. Up to 10 meters you don't normally need to bother too much, but definitely if it's over 10 meters you do need to do this thing. So you just bend it over like that and make sure it's tightly secured across the A, B. You can do it this way here. I just found this one easier. This is the CTs at the top, current transformers, and this is 3-phase CTs. So these 3 there go to the AC main input, and that's part of the second channel. That's monitoring a single phase inverter on phase A, that one there. Sizing the battery. Now I've made it really simple. I used to go through all the calculations for it, but look, customer language is you're talking about the kilowatt hours, right? But when you're talking installer language, it's different. Each module it goes in a series connection, so each one of them has a voltage. The more modules, the higher the voltage. Okay, so we have this chart here which we can send out to you. If you don't have it already, you can download it off our website, and it's got 3 options: no, yes with a star, and yes in green. Okay, What the no means is the voltage range. The voltage range isn't high enough. We've got every possible configuration of battery and every inverter, okay? So all you need to do is cross-reference. So let's take as an example SH10T. Okay, so can you put a 2-module system on it? No, the voltage isn't high enough, okay? If we go down here, SHRS, you can see it exceeds the voltage. The voltage is too high. So anyway, back to the SH10T. Supposing the customer says, oh, I can only afford 4 modules, that's fine. So you can put 4 modules on an SH10T and it says yes. However, if it's at night and there's no solar and there's a power failure, the maximum power, the only source of power is the battery, and the maximum 4 modules can give you is 7.68 kilowatts. Okay, so if they do want 10 kilowatts in an off-grid situation, you need to go up to 6 modules, okay, or 7 or 8. So that's how easy it is. Okay, battery connections. Couldn't be easier. You've got positive, negative communication and an earth. The COM cable is pre-terminated and included in the box, as is the earth. Okay, our batteries all have a built-in DC isolator, so as long as you've got the battery beside the inverter, you don't need any external isolators. Power, just use your normal solar cable for that, and we include the MC4s or whatever, or the John Hon ones. So that's easy. You just connect between there and the inverter. The COM cable, it is pre-terminated, as I said. You'll get this at the other end of it. That end's got an RJ45. You just assemble the weatherproof boot on it and you plug it in. Older ones were round, newer ones are square. And on the battery COM, we only use pin 1 and pin 2. We use this configuration here, 568B. And pin 1 and pin 2, which is can high, can low, is white, orange and orange. So you see there, white, orange, orange. And if you go to the inverter end, you see can high, can low. So you just push in, you terminate it with the bootlace, and you push it into can high, can low. And that's that done. Okay, different configurations on different inverters. DC connectors, we do provide them in the box. Some of them you'll get 2 different connectors because it allows for 2 different inverter types, and it'll be clearly marked on the packet which one they're for. Parallel connections, so you're going positive to positive, negative to negative. If you do positive to negative, nothing will happen except a red light will go on. That's all that happens. It won't operate. It will just show as a fault. So make sure you're on a parallel connection there. SBH range, you terminate. These are in the box, these bootlace things. You just crimp them there and then push them in and tighten up the glands. Make sure the glands are tightened up so that any water does not get in. The only place, after thorough testing, the only place we ever were able to detect water ingress was if you hadn't tightened up those rubber glands. Okay, so make sure you tighten them up. It is in the standards, it is in the manual to tighten them up. Communication, same, can high, can low. You will also get in the box, this is the SBH range. You will get this little thing here, which is a termination resistor. It's an RJ45 and it's got a little black thing on it. So you just put it into the boot there and you'll see that the communication port is got in and out. Out goes to the inverter, and in you plug that little termination resistor in there. Okay. Dongle. All Sungrow residential inverters are supplied with a Y9S dongle. The dongle is used for commissioning and to connect to the iSolar cloud. It communicates on 2.4 gigahertz. Okay, so normally you're looking at just a Wi-Fi communication to the customer's router. The range is 10 meters, so if it's longer than 10 meters or there's a lot of obstacles, you can purchase a Wi-Fi extender because you do need a good Wi-Fi signal for everything to work properly. If the end user has a 5 gigahertz only modem, you can purchase dual band Wi-Fi extenders. They work perfectly well they've been tested here at Sungrow. Another option, if you unscrew this thing at the bottom, is an Ethernet port, so you can just hardwire to the customer's modem there. That's another. And the third option is a 4G dongle if there's no internet. You can purchase these as a spare part. They come with a 5-year prepaid SIM card data plan on them. Okay, so power the inverter up. The blue LED should pulse. Okay, that means it's in standby. And you use your iSolar Cloud app to do the commissioning. So 3 parts to the commissioning, a Sungrow system. It'll take you through it. You just need to go through it and follow the prompts. You create an iSolar Cloud plant. You connect to the end user's modem, and then you initialize the inverter, i.e. set the grid standard. And to do that, always you tap that little plus, and it'll take you through the system. It's really easy. You just put the information into each you populate each window with the information, and it'll work fine. On the initialization settings, you set obviously the country, where Australia, New Zealand, Australia A, whatever. This is an old screenshot, by the way. If you do need to set the feed-in limitation, this is where you set it there, like so. And if there is an AC coupled system, like another grid inverter, you've got to put the AC power of that in there. Now, if you do have a feed-in limitation value and you enter it in there, and you enter this in here, it will automatically change this on its own. Enable backup mode, it is disabled by default, so you need to enable that, and then you basically turn on the device. Give it a few minutes. It'll take on the first start up, it'll take a couple of minutes to start up. Once it's up and running, update all the firmware. You do need to do this because the inverter you've installed might have been made 6 months ago. Especially if you're doing an energy bridge, you will need the new firmware, otherwise it won't work. So update all firmware, the inverter, the dongle, the battery, and then give it a couple of minutes and go into the iSolar Cloud just to make sure everything's reporting as normal, including the energy bridge. If you have installed an energy bridge and this is not showing, you need to find out why. But you're looking for ticks, green ticks. It does take a while for meaningful data to show on the cloud, so don't worry too much. Once you've done that, you're ready to test the system. Now, whether you've got energy bridge or not, doesn't matter. You want to test the backup. So you've created the plan and you've initialized and you've updated the software and you've enabled the backup mode and you've got everything up on iSolar Cloud, and then you do the test. To do that, all you need to do is put the AC switch off. Obviously talk to the owner and let them know that you're going to do it. But the whole system should change over within 10 milliseconds, okay? So you just flip the AC off, that's it. Is it working in off-grid mode? Yep, you're all good. So you can switch it back on again. It will take 1 minute to re-establish to the grid. And after a while, you start getting some meaningful data coming up on the iSolar Cloud. You can check that it's charging the battery, it's supplying loads. Importantly, you do need to see this here. If this has 2 dashes on it, or if the battery has 2 dashes on it, right, it means it's not communicating. It has to have a number, even if it's a 0. So if you see 2 dashes, it's not talking to the metering device, okay? You can do the settings if you want. You can log into any piece of equipment, get all this information here. If you're looking, insulation resistance, all the rest of it, current voltages. If you click on that little squiggly icon, you get the graphical data of it. And there's the firmware update. You go to the update page, it will tell you if there is an update available, and if so, you just hit the update and update. Give it a while, it can take a few minutes to update. And that should be you pretty much done in your installation. Now, to claim your CPD points, you go to this web page here, service.sungrowpower.com.au, and you click the training webinar tab, and you download the evaluation form and then return it back to training at Sungrow Power. If you have trouble finding these, this is the training email. Okay, please only use it for training and not tech support. It's just training@sungrowpower.com.au. Once I get the evaluation back and I can clearly see that you know what you're doing, I will send you out your CPD certificate. It's actually moved from there. It's actually in the knowledge base now. Okay, it has moved from there. But this is what the page looks like, and you just click on, if it's this one here, you just click on that there, evaluation form, and download it, fill it in, rename it with your name on so I know who sent it, and send it back to that email, and I'll get your CPD out for you ASAP. Just as a final word, if you do off-grid, we do have off-grid training as well. All of our hybrids operate in off-grid mode. It's almost identical to doing it grid, except instead of connecting it to the AC, you connect it to a generator, and there's a control cable to start it. So if you're interested in off-grid, give me a hoy and I'll give you a full training module on that. If you need more help, 1-800-786-476 is tech support. It is open 6 days a week, including Saturday, or you can email service@sungrowpower.com.au, or you can join this. Now, if you do want to join this, please tell us that you are an installer and agree to the group rules. We don't let end users on here because we put information about grid settings up there. We don't want them knowing that. So please do. It will tell you to put your installer accreditation number in. Please do that and agree to the group rules, and we'll get you into the group. So thank you all very much for your time. If you get any further questions in relation to training, you've got the email there, training@sungrowpower.com.au, or if it's just tech support, use the tech support hotline.